On today's event, we'll be talking about bringing context to generative AI and practical applications of RAG. But before we go into the deep dive of this topic by our amazing speaker, I'm going to be handing you off to John Carney. John Carney is the PyData Manchester lead organizer, and is also PyData London conference chair as well. So he's going to be taking us on the journey of PyData as a whole, what the organizations stand for, and he's going to be telling, discussing with us, giving us a full overview of what the organizations stand for. So John, you have it from here.
Hey, thank you very much. Give me a moment, let me share my slides. I promise it's not going to be very many slides, just to give people a bit of an idea of what's going on with PyData, what we stand for, what we do, and why. And then we can get into Abizar's fascinating talk on context and LLMs. So yeah, first of all, thank you very much, Grace and Philip, for organising. It's fantastic work. I know a lot of stuff that goes into it. One of the things that goes into it is sometimes your speakers aren't very organised and aren't a very good partners. So I apologise that I didn't send over actually a good bio to introduce me. I really appreciate what you did. It was very accurate. So for those of you who haven't met me before, my name's John Carney. I'm one of the founders of PyData Manchester, and I am one of the current chair of the PyData London conference. The London conference is separate from the London meetup, although we do work closely together. But I'll come to that stuff later on. So hopefully everyone can see my slides, because I never know how it works with Google Meets. Sorry, Google Meets, Teams. Excellent, thank you. So PyData is a global education charity, a global education outreach of non-focus. What does that mean? Broadly, all of us here are in some way interested in data. Some of us do machine learning, some of us work on large language models, some of us do data engineering, some of us do data analysis. There is such a wide variety of skills and tools that go into this, and it's ever expanding. I first got involved with PyData Manchester back in 2018, and what the definition of a data scientist was then is totally different from what a data scientist is now. We are moving so quickly. But from my mind, from my perspective, one of the key things has been, through the heart of my experience, has been the tools that I use through PyData that the community has created and shared and made available to the open source community. And I think that's worth celebrating. And I think there's an awful lot that we as a community can do to help each other. So before I start rambling, as I said, I organised PyData Manchester as part of the team. I organised PyData London as part of the team. We also...
We're going down?
Sorry, there's 75 people here. Please could you put any questions into the chat, please?
Would you be going down today?
Sorry, would you mind not asking questions until the end? Yeah, so I organised PyData London conference as part of the team, and we've also organised some a sports analytics conference in Manchester, and there's more and more events coming all the time. Just this year, I believe we've had five new meetups in the UK PyData community, which is fantastic. And again, people like Grace and Philip taking the step to take us to the next stage. There's 73 people here from across the country, sorry, across the world. So yeah, it's fantastic. The more we do as a community, the better. The more we can help each other. So worldwide, we have around 200,000 members, just over, of people who attend PyData events, who get involved. There are exactly 161 groups from Vancouver and Seattle all the way to Tokyo in Japan, spanning all time zones. It's fantastic. We're across 60 countries. Tonight, there are 3 different events happening in Yerevan in Armenia, in Natal in Brazil, and in Atlanta in Chicago. I'm pretty certain this is the biggest, best attended. So again, that's a fantastic testament to what Grace and Philip have done. So I want to take a moment and talk about NumFocus, which is the kind of the entity that's behind PyData. Sorry, Pablo, would you mind repeating? Thank you. NumFocus is the kind of the entity behind PyData. So what NumFocus does is the fiscal sponsor behind most of the open source software that we use. So that'll be software packages such as Pandas, NumPy, scikit-learn. This was, I believe, the full list of packages. I know there have been more packages added since we first created this. I started using Pandas in 2012, and I can tell you I would never have been able to get into data science, data analysis without some of these open source technologies. I'm sure a lot of them will be really, really familiar to a lot of you as well. Some of the things that, like, you might ask, what does NumFocus do as a fiscal sponsor? So NumFocus basically helps to provide finance, and it can be providing grants, but it can also be helping to provide administrative services, because all these open source software packages are created, contributed to by people like you and me. Most of it is, putting in pull requests, fixing bugs, adding new features of packages that we use and we care about. But behind the scenes, we do have administrative teams helping us. Often they're volunteers, but NumFocus helps to bring together resources and help people who are focused on software navigate a lot of the administrative and fiscal burdens that come with that. That includes legal services, includes operational services. There's all kinds of stuff. So one thing that PyData does, and how PyData relates to NumFocus, is PyData is kind of the educational program of NumFocus. So across all of the different PyData meetups across the globe, what people like myself, people like Grace, Philip, and all of the many different organizers across the world do is, we try to put together talks. We try and help both attendees learn, and we as organizers learn too. So yeah, there's education in the widest possible way to include as many people and to help us all learn. So we did mention about I did mention about the PyData London conference. You may have noticed I'm based up in Manchester. I'm not based in London, but the PyData London conference especially, I mean, as I've said, all PyDatas are as welcoming and inclusive to everyone. Certainly when I visit London, I'll try and go to PyData London, the meetup, if I'm there. But the PyData London conference is a chance for people across the UK and across the world to come together and talk about data. The last event was just over a month ago, in the 6th to the 8th. And if I do say so myself, it was lovely. I saw some of you there, and hopefully we'll see more of you next year. I'm not sure what else to say. We've got more and more events across the UK. I know we've got an international audience, so I know there'll be other events closer to you. But I guess that's kind of that's a background to PyData. So I apologize, Grace. I'm not sure how you're going to handle this. Do you want to do questions now? Do you want to do questions in the chat?
We can have questions in the chat if there is anyone that wants to ask John any questions regarding PyData. You can have that for about 5-10 minutes. Any questions regarding PyData, anything that John has said that you would like a little bit more um you like a little bit more examples or answers to? This is the best person to ask right now. He's got amazing experience. He's been in the community for ages, I'm sure. Okay, Sandeep is asking, when is the next PyData Manchester scheduled for?
Very good question. We are currently organising a venue. The emails we've been sending are looking at the 30th of July, but it's not confirmed. So that's a little sneak peek.
Okay. Sandeep, this is your chance. You can connect with John, and John can give you, more information. He is always responsive, I tell you. You
I try
send
my
him
best.
send him send him something on LinkedIn, give him a few hours, at most, maybe the next day you will get a response, definitely. So he will definitely give you a response. If you would like to also participate in PyData Manchester as well, I'm sure John is the person to speak to. He's welcoming. He's taking new members last night. Yeah. So you can speak to John about that. Is there any other questions? Anything else? Somebody, any other questions you would like an answer to? Anybody else? Any other questions? Okay.
Again, sorry, yeah,
Yes.
feel free to ask questions in the chat. Feel free to add me, DM me on LinkedIn. Yeah, I'll try my best. But otherwise, thank you very much, everyone, for coming, and look forward to this talk.
Thank you so much, John, for joining. Thank you so much for giving us that very detailed overview of PyData and everything that the community stands for. Uh, I would appreciate if everybody please mute themselves so that we can all enjoy, this beautiful session with our speaker. I can say our speaker is ready, and he looks like, he's ready to give us a deep dive into bringing context to generative AI and practical applications of RAG. What I'm going to do is I'm going to be handing us over to our moderator for this event. Olorun Femi, I don't know, are you there, Femi? Femi, are you? Yeah, so I'll be handing you over to in the good hands of Femi to moderate this event. Thank you so much for joining, guys. Thank you.
Thank you very much. Thank you very much, Grace. Once again, welcome everyone to this amazing first event for the PyData community. I trust you're having fun and connecting on LinkedIn. People are dropping their LinkedIn profiles. So to try to network, try to connect and follow people around. So next we'll be bringing in the main speaker for today. Just give me a second. So we'll be bringing the main speaker to give us the presentation. I'm trying to present my screen here. All right. So, Abuza, are you ready?
Yeah, I'm ready. Do you want me to share my screen?
Let's get it started.
Okay, great. Let me just share my screen. Sorry, bear with me one moment. Sorry, I'll just have to rejoin because I'm using a new browser and it just needs the security access. I'll just be one moment.
All right. So briefly, so keep connecting while we wait. Glad to see everyone on board.
Yeah, sorry about that.
All right, no problem. It happens.
Hopefully you can all see my screen. Can you see that? Sorry.
Not yet.
Yes, we can see.
Oh, you can see. Great.
Oh, great.
Yeah, okay. So good evening, everyone. Thanks so much for being here today. So I'm Abuzar Sultan, but you can call me Abs. I'm a data scientist at Allianz, and it's a genuine pleasure to be speaking here at PyData Milton Keynes. So currently, right now, we're living through a remarkable moment in technological history. In the last few years, we've witnessed the explosion of generative AI. Models like ChatGPT, Midjourney, and Google's own Gemini models have captured the world's imagination. They can do many things from writing poetry to composing music and generating images. And this has triggered a wave of excitement to integrate this magical capability into every conceivable product. But for those of us in this room that work with data, once this initial awe subsides, a challenging question emerges. So how do we actually use this reliably in a business context? Tonight, I'll be going through that journey to answer exactly that. I'll start by defining the problem with the Achilles heel of modern LLMs, and then step by step, using Python and LangChain, we'll build a solution from the ground up. So for those of you that are newer to the space, you might be wondering what a large language model is. At its heart, it's an incredibly sophisticated pattern matching engine. It's built on the transformer architecture, which you can see on the left here, and it uses a mechanism called self-attention to weigh the importance of different words in a sequence, allowing it to understand grammar, syntax, and semantic relationships with an uncanny ability. It learns these patterns by processing a staggering amount of text from the internet, and the result is a model that is a master of language and form. However, one thing to remember, it's not a database, it's not a search engine, and it can't reason as we as humans do. Its knowledge is static and probabilistic and prone to error. Our job is to mitigate this weakness while leveraging its phenomenal strengths. By the end of this session, my goal is for you to not only understand the what and how of RAG, but to understand the deep why behind every architectural decision, empowering you to go back and build your own context-aware AI applications. So here's the roadmap of tonight. So tonight's session will be a logical progression moving from a simple problem statement to a complete working solution, and finally a glimpse into the future. I'll start by building a simple AI chatbot so we can see its limitations, as it's crucial we all start from the same baseline. We'll witness firsthand the phenomenon of hallucinations and establish why a more robust architecture is necessary for any serious applications. Then I'll introduce the solution, which is RAG, and I'll spend a good amount of time breaking down each step in the name itself. So we'll individually break down retrieval, augmented, and generation as well. And we'll discuss why RAG is often the right architectural choice for knowledge-intensive tasks compared to alternatives like fine-tuning. Then we'll complete the talk and we'll build a full complete RAG pipeline from scratch. I do have a notebook that I'll share as well, and we'll go through loading a PDF and creating a dynamic private knowledge base. And then finally, we'll end with the future of RAG in enterprise, which just for this presentation is agentic RAG. Of course, there's many more phenomenons going on at the minute, but I'll focus on agentic RAG tonight. And then by the end of tonight, you'll have a complete picture from foundational principles to the state of the art in applied generative AI. So we'll begin with the foundation and the floor. So you can scan this QR code to get access to the notebook as well if you want to follow along. I'll leave the slide up for a few seconds. Okay, hopefully you'll be able to scan that and get access to the notebook. So let's start by building the baseline chatbot. It's essential we start here to appreciate both the power and the fragility of raw language models. What you're about to see is just about how LangChain does a lot of the heavy lifting for us, It abstracts away the complexities of API calls into clean Pythonic objects. let's break down the code on the left line by line. So we initiate by importing all the libraries that we'll need, and then we set the API key. So here we just use os.getenv, so we'll get it from the .env file that we set in our code, and then this will allow us to start interacting with the Gemini API. So we're using Gemini today. You can go to the AI Studio and generate an API key, and it's free to use, so you should all be able to use that. So now the main event is the chat Google Generative AI. So as you can see on the left, we initiate the chat object. So that's the thing that will allow us to interact with the Gemini model within code. So it's got two key arguments. The first is the API key, which we set before, and the second is the model we're going to use. So here I've just used the Gemini 2.5 Flash model. So that's a very intelligent model, and it's very quick, so the latency is very minimal, so you'll get a response almost immediately. And then finally, what we do is we can just use the chat.invoke. So we just invoke the response that we pass into it. So here I've just asked it to write a short poem about PyData. And then what LangChain will do, it will construct a proper JSON payload, and it will make the request to the Google Cloud API endpoint, handle the response, and pass it back to us in a Python object. If you look through the notebook, you'll see it's an AI message. That's not just a simple string. It's a structured object, and it contains the content, which you can see on the right here, which is the short poem it created. But it also includes valuable metadata, such as safety ratings, and most importantly, usage data. So the usage data tells you how many tokens the request used. So a token is a fundamental unit of text for an LLM. If we're talking roughly, it's equivalent to about 4 characters of English text, which equals 1 token. And all API usage is billed based on the number of tokens processed. So you'll be charged for the input tokens, so the ones that you put through to the model, and then the output tokens as well. As a baseline, the input will be almost always cheaper than the output tokens. So you can see on the right the poem it wrote. I won't read it since I'm not a very good poet, but yeah, hopefully it put a smile on your face as it did mine too. So next we'll go through the flaw of raw LLMs. So as we said, they're incredibly powerful, but the biggest boundary of all is the knowledge base. So the knowledge that an LLM holds, what we call the parametric knowledge, was sealed the moment its training process concluded. So you can think of it like a photograph of the internet at that time. Anything that happened after that photo was taken, it's simply outside of the LLM's reality. This leads to the most discussed and most dangerous failure mode of LLMs that we know today, which is hallucination. I want to be very precise about what that means from a technical standpoint. So as we saw in the beginning, the LLM is a probabilistic model. Its goal is not to tell the truth, it's just to predict the next token in a sequence that is most probable. When we ask it a question, it generates a response, one token at a time, each time picking from a probability distribution over its entire vocabulary. If the question is about something it has deep knowledge on, something like what is Python, then the most probable sequence of tokens will also be the factually correct one. But if we ask it something it has little training data on, or is outside the knowledge picture at that time, the model will remain the same. So it will carry on doing that probabilistic account, trying to get the next token and give you an output. The output will look grammatically perfect. Look, it will be confident, but it will be completely wrong. It's not lying. It's just following its objective in a low data situation. So I just want to demonstrate this to you. So hopefully some of you heard about what Kimi K2 is. If you haven't, it's a niche recent model that was released by the Moonshot AI team. And if we look at the output on the right, it gives us an answer based on what it thinks Kimi K2 is. So it speaks about its massive context window and its strong Chinese language capabilities, and it all sounds authentic. but it's a hallucination. It's a fabrication built on scraps of information it has about other AI models. It misses the core facts. The Kimi K2 is a mixture of expert models and has 1 trillion total parameters and was trained with a specific optimizer. The model is just filling in those gaps with plausible fiction. You might think, can't I just tell it in the system prompt to just say, I don't know if it doesn't know the answer? This can help, but it's a brittle solution. The model might think it knows the answer based on a few related keywords, so the instruction won't trigger. Or in a long complex conversation, that initial instruction might lose its influence as the prompts and the chat history grows. So we need something that's a bit more robust and will allow us to sort of fundamentally change the task from a recall from memory to a synthesize from provided facts. So now I just want to talk about what the solution is. And in our case, I'm going to present RAG as the solution. So I just want to talk about the differences between RAG and fine tuning, because I know we're a technical audience here and some of us may have that question. So one of the most important patterns in applied AI today is RAG, and I want to spend a good time deconstructing it and then comparing it to its main alternative, which is fine tuning. So I want to start with an analogy. So we can think of the LLM as a brilliant world-class research assistant. It's a linguistic genius. It can read any text, understand its nuances, synthesize information from multiple sources, and write a perfectly coherent, eloquent summary in any style you ask for. But it has a terrible memory. It's read almost every book in the world's largest library, but can't recall specific details from any single one. If you ask it for an answer, it will give you a generic blended answer based on all the fuzzy memory it has of everything that it's read. This is the raw LLM. Now, RAG is the process we build around this assistant. The retrieval part is like hiring a dedicated lightning-fast librarian. When you have a question, you don't give it to the assistant, you give it to the librarian. The librarian's only job is to go to the library, which in our case will be the curated list of documents we have, and it will find the exact pages containing the answer that we're looking for. That's the retrieval step in RAG. The librarian will then bring those pages back and hands them to the assistant, which is the LLM. That's the augmentation step. And now you ask the assistant your question again, but you give it a new instruction. You don't ask it to give you an answer based on its own memory, but you say, using only these pages in front of you, answer this question that I have for you. The assistant's task has now changed. So it's more like an open book exam now. They have the factual pages in front of them, and they use their incredible language skills to give us a perfect answer. That's RAG. Now, a common question from people from a technical audience will be, why not fine-tune instead? So fine-tuning is a different process. Fine-tuning, we can think of it as in sending our assistant to medical school. We'll take the base model, which will be the LLM at that point, and we'll continue the training process on a smaller curated data set, say a collection of medical textbooks. This adjusts the model's internal weights, so the assistant will learn the style, the jargon, and the patterns of reasoning of a doctor. It's incredibly powerful if you want to change the model's behavior or teach it a new skill. However, it's not ideal for factual knowledge. Those facts that we provide it in the new training data will get blended into the model's weight and can be hard to recall precisely. Furthermore, it's static, so let's say a new medical study is published tomorrow. We'll have to send our assistant back to school and start the costly and time-consuming process all over again. So now I just want to go through a minimal example of what RAG is. So now that we've established the theory of providing context, let's prove it. So before we build the automated system, what a good engineer always does is builds a simple possible prototype to validate the hypothesis. That's exactly what I'm going to do now. So our hypothesis is if we manually provide the correct to the LLM within its prompt, its output quality will increase dramatically and hallucinations will be eliminated. So let's go through the code that I've got on the left. So I've created a source knowledge So for this, I've just got a collection of strings, and each one contains a key fact from the Kimi K2 model, which I just took from their page. So in a real application, this would be the content that you'd like to train your RAG on, or the information that you'd like to provide to the LLM to give you an accurate answer based on your content. So the next important piece is the creation of the augmented prompt. So the way you can think of this, sorry, is as a meta prompt or a structured request. So what we're doing here is we're architecting the information and giving it back to the LLM. It's not arbitrary, it's designed to align with how the model processes information. It has three distinct parts. So the first is the instruction. So we say, using the context below, answer the query. This sets the task for the model. Second, the context. Here we inject our source knowledge that we defined earlier. And this becomes the universal facts that the model has access to perform the operation. It's sort of like the open book, if we think of it as like the open book exam. And then finally, we have the query. This is the original unmodified question from the user, which in our case was just, what is Kimi K2? By placing it last, it becomes the focal point of the model's attention, guided by the preceding context. So what we do in LangChain, so some things you need to be aware of in LangChain. So we wrap this augmented prompt in a human message object. So I'm sure you've all used things like ChatGPT online. So the human message is when you type the prompt in and send it to the LLM. So that's the way you can think of the human message. Then we call the chat invoke like we did before. So that sends our request back to Gemini so it can process the message that we sent. So all the model sees is that augmented prompt that we provided earlier. It doesn't know that we performed this RAG pattern to provide it extra information that it didn't have access to before. And the result, as you can see on the right, is just night and day. So previously it was just hallucinating things about a large context window. As you can see here, the context window isn't that large. It's quite moderate. It's 128K context length. And it also includes the information about the new optimizer and everything like that. So this basically proves our hypothesis that we defined earlier. So it proves that RAG is a genuine thing that works. The only problem here, if we use it like this, it's completely unscalable. We can't have a human always Googling facts and copy and pasting them into the prompt for every user query. So for the rest of this presentation, I'll talk you through how we build that automated librarian that performs the retrieval step for us. So yeah, we'll go on to building a complete knowledge grounded chatbot. So where we'll start is with vector embeddings. So this is the heart of the retrieval step. So the fundamental challenge we need to overcome is this. How can we get a computer which only understands numbers to possibly comprehend certain related phrases? So for example, challenges in AI risk assessment is one sentence, and then our second sentence will be evaluating the dangers of artificial intelligence is difficult. We as humans, we realize those are very related because they're talking about the risks of AI. But if we were to just do a traditional keyword search, sorry, that would fail here because they don't really contain much of the same language. But what the vector embeddings will allow us to do is they will allow us to get a list of numbers that serves as a numerical representation of the piece of text that we provide. The process of creating this is powered by a type of deep learning model known as an embedding model, which I'm sure many of you will have heard of. And it's based on the same transformer architecture we saw earlier. So you can think of it as like a translator for the computer. It takes the text from human language and maps it into a specific point in a high dimensional mathematical space, often called a vector space, as you can see on the bottom left here. So, sorry.
Can you
Sorry,
please use
yeah, sorry, yeah, go ahead.
Can you use the mouse? Some people cannot follow.
All right, sorry. So yeah, yeah. Sorry, yeah. So this is the vector embedding. So for example, we've got the word apple here. Then it will output that into numericals that the computer will then be able to understand. So as you all know, a computer is sort of like a binary thing where it understands numbers better than it would text. So all we're doing for these sentences is, or for the documents that we want to embed and provide to our LLM, is just converting them into these vectors that the computer will then understand. And then what the bottom left shows is, in a vector space, how do these relate? So for example, king and queen, they will be closely related because we know that a king and a queen belong together. If we're talking about language, or if we're talking about cities, we know Beijing is the capital of China, so they're closely related. So that's how a vector space works. And it's the foundation of all modern semantic search. So not just for LLMs, it's also used in recommendation engines, search engines, as well as clustering algorithms. And we will leverage it to build our librarian. So on the right, I've just gone through the code of how I set this up. So what we're using here is a specific model, which is the sentence transformers, this specific model here that you can see, and that's from Hugging Face. So Hugging Face is an open source library, so this is free to use, so it won't cost you anything. So let's just walk through the code here so we all get an understanding of what's going on. So we import the Hugging Face embeddings library at the top. So what that does is it will download the model for us from the Hugging Face hub, cache it locally so we don't need to re-download it every time, and provide a standard interface for us to use in the code. And then we create an instance of this class. So we create the embeddings class here, as you can see, and then we pass it a few specific arguments. So the model name we said here, and then the model sort of arguments that we want to pass. What I've passed here is device CPU. So all that means is for this demo, it will run on your CPU. So that will work on anyone's laptop, regardless of their hardware. In a production setting, if you are using Hugging Face, you might want to use GPU. All that will do is allow it to run much more faster. Then once we've got these vectors, what our next step will be is to choose a vector database that we want to provide all these vectors to, so it can create that vector space as we see on the left here. So we'll create that for our own documents. So we'll pass in these raw vectors that our embedding model will create, and we'll pass them on to the Chroma database. So what the Chroma database is, again, it's a open source database, and it will allow you to do, if I go back, sorry, it will allow you to do this sort of thing, but from our embeddings that we want to create on our specific documents. So let's say if a user asks a question and they want to get the top 5 most relevant chunks. So the naive approach to that would just to do a brute force search. So take the user's query vector and calculate its cosine similarity to every single one of the 1,000 chunks that we have in our database, and then sort them by the top 5. This would take too long and would be too costly, computationally speaking. So we need a data structure that is purpose built for this fast vector search. And this is where our vector store comes in. So what these vector stores will use, they will use sophisticated indexing algorithms. So Chroma itself uses the HNSW algorithm, and it will create a searchable map of the vector space. And that allows us to approximate a nearest neighbor search that's incredibly fast and almost as accurate as brute force search. Like I mentioned, I've chosen to use ChromaDB here because it's open source and incredibly easy to set up. On the right, you can see it's just a few lines and you have a Chroma database set up. You can set it up entirely in memory, or it can be persisted to a directory as I've done here in your code too. In enterprise, it's not usually best practice to use something that's persisted in your local directory because you want it on the cloud. So there is distributed solutions that are available, such as Azure AI Search or Pinecone or Weaviate. But the core principles that we're learning today are exactly the same. So let's do a deep dive into how we now populate our knowledge base. And this is the data engineering part of our pipeline. So first what we do is we load our PDF in. Once we've loaded the PDF in, we will then split it into chunks. So I just want to speak about the chunking now. So we just use the PyPDF loader, which is provided from LangChain again. So again, it's very easy to set up. It's just a few lines. And then we use the recursive character text splitter. So what this does is it allows us to split the document. So you may ask, why even split the document? Why not just pass the whole document within the prompt? It's a good question, but one thing that we do need to be aware of, many LLMs do have a context window. All a context window means is it's the amount of tokens it can process for you. So models like Gemini have very large context windows, I think over 1 million, whereas other models such as ChatGPT have a much smaller one, which may be something like 128,000 tokens that it can process. The other reason why you may want to split your documents is, let's say you've got 100 documents. Even if the context window is 1 million, it wouldn't be able to process all your 100 documents. That's the reason why we split. So we break our large document into smaller pieces so it can fit into this window. And this splitter, the recursive character text splitter, the way it works is quite clever. So by default, it will split on double new lines, so paragraphs. So for example, if you read a book, the way you'd split the page when you look at it is by paragraphs. So it will try to do that first. If the chunk is too long, or if that paragraph is too long, what it will then do, it will split on a new line. So on the next new line. Again, if that still is too long for the chunk, then what it will try to do is split on spaces. So the spaces in between the word. And again, if that's outside the remit of the chunk, then it will split on characters as a last resort. So on the right here, you can see we set a chunk size to 1000 in ours and a chunk overlap to 200. All that means is, let's say, for example, here we can see this blue highlight, for example. That's our first chunk. Now, in our second chunk, we also do an overlap here. So now within the first chunk and the second chunk, if there was any important information in this sort of overlap stage here, it would be persisted in both chunks. So we'd never lose that important information. Hopefully that makes sense. Sorry, bear with me one moment.
Hello.
Yeah, sorry, bear with me one moment. And then finally, what we do is we add the chunks to our database. So we created our vector store earlier here. So as you can see, we created vector store equals the Chroma DB. So now all we do is vector store, add the documents. And what LangChain will do is it will iterate through every document this text splitter creates for us. So it will be a chunk size of 1000 with an overlap of 200. So it will split the PDF into those chunks. And then we add every individual document into our vector store. And then finally, once it's all done, we just print this message so we know it's done. So then we go on to the augment step of RAG. So what we do here, as we saw earlier, is we just create the augmented prompt, which is the meta prompt, as you can think of it. So using the logic we established earlier, we just pass the top 5 most relevant chunks we retrieve from our Chroma database. We let Chroma do the heavy lifting here. As you can see, we just do vector store.similarity search. So it's quite easy in LangChain. It takes away a lot of the abstraction. And then we just sort of format the chunks that it creates by splitting them by new lines, just so the LLM knows when a new chunk starts and where one ends. And then, like we did before, we just pass in those to the prompt itself and then return the prompt from this function. On the right, I explain how the similarity search works if you're interested in that too. And then finally, we get onto the generation stage. So this is the actual response that we get from the LLM. So we've assembled our pipeline, and it's time to execute our system and observe the result. This is the moment where we'd ask the system to perform a task that would be impossible based on the baseline LLM, as this task requires deep domain-specific knowledge extracted from a document it has never seen before. So for example, this is our query. If I was just to ask that to ChatGPT now, it may give me an answer, but I don't know where that answer is coming from, so I can't really trust it. Whereas with the RAG approach, because we provided it all our information, we know it's based on the facts that we provided. So what we do here on the left, I'll just go through the code so everybody understands. So again, we add the prompt, so we just wrap it in a human message function. So the content just equals the augment prompt function that we created previously, and we pass this query. So the query will then just populate this part. Then we create a new chat history. So I just called it rag messages here, and I provided it a system message. So a system message, what that does, it sets the overall persona and high level instructions for the assistant, for the LLM you're using. So here it's just a simple, you are a helpful assistant, but for your specific use cases, it could be anything. So for example, if you're creating a financial analyst chatbot, you could tell it you are an expert financial analyst and you must be formal and cite your sources from the knowledge database. So that's what the LLM will follow based on your system message. So now, because we've got our chat, so in the reg messages, we've got our prompt and we've also got the system message, which we just append after the human message, sorry, which we just append after our system message. And then we again invoke the chat, which is Gemini in this case, for a response. So as we know from our prompt, we just give it the source context as well as the user's query, and then it's time for it to output an answer for us based on our context and based on the query that we have. And on the right, you can see based on this query what the answer was. So if you go through the PDF, which is included in the GitHub repo, and you were to read it, I'm pretty sure you would come to these same conclusions on what are the 5 points the report makes about that query. So here, what I want to do is address 2 questions that I'm sure some of you may have if we're thinking about creating a productionized or a RAG pipeline. So you may ask, what about the life cycle of the knowledge base? So as we all know, when you're in an organization, they will constantly be releasing new documents, or they'll be updating old documents. So what happens in that case? Because in our current script, all we do is we load the data once, and then we assume that's how it's going to remain for eternity, basically. But in a real system, what you'd do is you'd build the data pipeline here. So you'd have a process, perhaps triggered by a file change event or running on a nightly schedule, that reruns the loading, splitting, and embedding process to keep the vector store in sync with the source of truth. And then another question you may have is this fast enough? So for example, is that step where we do the retrieval from the vector store fast enough? Or would it just add on so many seconds to our response time that it's not worth doing it? So the great thing about RAG is it's very fast. So the embedding and vector search steps are incredibly fast. They typically take milliseconds. The main latency you'll see comes from the LLM call itself. So depending on the size of the context and the length of the generated answer, that's where you'll see the main things. And what we found in Allianz when we've created these RAG sort of systems is it's well within acceptable limits for real-time conversational experiences. So now I just want to talk about how generative AI is evolving and how what we're seeing are the next steps, especially in RAG. So what I'll go through now is just explaining what an agentic use case sort of is. So everything we've built so far has been what I'd call passive RAG. So it is incredibly powerful, but it's very linear. So the way we can think of the linear path at the minute is a user asks a question, our system retrieves context to answer it, and it's basically just a knowledge engine. So with the user's question and the system retrieve context, we then just pass that to the LLM to generate an answer for us. But the paradigm shift that we're seeing now is moving beyond just simply answering questions about work towards an LLM doing the actual work for us. And that's the domain of agentic RAG. So you can think of an agent as an autonomous system that uses an LLM as its central reasoning engine to achieve complex goals. So instead of a simple retrieve, augment, and generate pipeline, an agent operates on a continuous loop, which you can see on the right here. So it goes through a think, act, and observe loop. So let's break that down on what that means. So the think stage, so the thought stage, the LLM will receive a high level goal from a user, as I just printed one here. And what it will do is, first job is to think and decompose that goal into sequence of logical steps or a plan. So it will take this query and think about a plan to how it can answer every request in that query. So once it's made that plan, then it will start its act. So it will start the action. So what the action will do is it will, for each step in the plan, the LLM will decide to use a tool. So in our RAG system that we created earlier can just simply become a tool. So it can just become a tool that an LLM has access to. It can go through splitting this query into, say, a RAG query. So we may just, the RAG section may just want to know what Project Atlas is and what the support tickets have been talking about recently. So let's say it was connected to the company's Zendesk and they had augmented or they had retrieved and augmented all that information into a knowledge base. Then the RAG system that we created earlier would just be a tool that the LLM calls in this workflow to get context about what's going on with the P1 tickets for Project Atlas. And then the observe step, which is the final step. So after the agent uses the tool, it observes a result. For example, in the RAG tool, it might return a block of text. And for example, here we've just said the issue, the context shows that the payment processing failure is the issue. So that's the observation. And with that observation, it just passes it to its next part of the plan. So that's how agents work within a workflow. So let's go through and break down how this would work in detail. So our goal here is our P1 support tickets for Project Atlas have spiked by 30% this week. Investigate the root cause, identify the lead engineer on the most implicated microservices, and schedule a 30-minute critical incident review with them in the first available slot on their calendar tomorrow. So if you think about our previous RAG system, it may be able to just answer based on the P1 support tickets, what is Project Atlas and why have those support tickets spiked 30% this week. That's all it would be able to do. It wouldn't be able to investigate the root cause or identify the lead engineer. and it definitely wouldn't be able to schedule a 30-minute critical incident review and go to their calendar and book that in for us. It just wouldn't be able to do that. So I'll just talk you through how it would work. So the process starts. So we know we're looking at the support tickets for Project Atlas. Then the LLM thinks, so I need to understand the ticket nature. So what's going on with those tickets? So it will then act. So it will use the RAG tool. And the query would just be summary of P1 tickets for Project Atlas this week. Then once it gets its response from those tickets, then it will come with an observation. So the context shows that the payment processing failures service billing v3 is the issue. So then it passes the observation into the next step of its plan. So now it needs to find the owner of the service billing v3. So let's say this company has a code base of who's working on each project, sorry. So and it's got an available API that we can call. So we just call that API and we'd observe that the owner is Jane Doe, for example. So now we go on to our next steps, which is schedule the meeting. So now what the agent will do, it will then use the calendar API and query Jane Doe's calendar to see when they're free or busy tomorrow. So it will then observe the free slots and the busy slots, find an available slot, and then it will think again. So now it knows it needs to book a slot in their calendar tomorrow. So now it will just use the calendar API, create an event, and maybe give it a title like critical incident review. And it will invite the project manager and Jane Doe, who is the owner of that service billing v3. And then the agentic loop ends there. So it's answered our query. And as we saw, RAG was just a single point within that full workflow. So it just opens up a wide variety of the different level of capabilities that LLMs are going to at the minute. So it's not just retrieving facts, it's also reasoning, planning, and interacting with multiple systems to accomplish a goal. This is the future of knowledge work, AI systems that don't just give us information, but act as our digital colleagues to execute complex tasks. So hopefully that was understandable for you all. Thank you all so much for your time and for your attention throughout my deep dive. I hope this session hasn't just demystified the how of building RAG, but also the why behind some architectural decisions. The code and notebook from tonight's presentation, as I said, they are on my GitHub page, so feel free to download it, experiment with it, and adapt it to your own projects. Like I said, the Gemini API that I provided, it's free to use. Chroma DB is free, as well as the Hugging Face embeddings, so everything is free to use. And again, you can find me on LinkedIn, so feel free to connect with me. If you've got any questions, you can always just message me, and I'm always happy to chat. And finally, a massive thank you to the organizers of PyData Multi-Cleans. I know it takes a tremendous amount of work to put on events like this, and it's been an honor to speak here tonight. And yeah, thank you. Have a wonderful evening.
Awesome. Awesome. Thank you very much for that amazing presentation there. We have some questions already in the meeting chat. If you won't mind to answer some of them. I'm trying to scroll up to read.
Can I start?
Of course,
Yeah, go ahead.
Yeah, so thanks for the wonderful presentation, Abuzar. You gave a good insight of how RAG systems help in creating real-time processes and automating them. I wanted to understand how someone who is new to LLM and wants to get to this kind of professional automation, what is the career path they should follow? How should we start in this direction first of all? What is the first step towards that?
The first step, I'd say, so the main thing about data, I'd say, is you need to understand how to code. So if you've got no experience in coding, I'd say first
Yeah,
learn
I have
learn
experience in
Python.
coding. Yeah. Someone
Yeah,
like I have experience in coding. I have done coding in C, C++.
yeah,
But I have not done coding in Python. But do I need to learn Python first before moving to this level?
You can find certain frameworks that do allow you to use C++ as well. You would have to find them. I don't know any off the top of my head, but I do know they exist. But I'd say for a lot of the models right now, it's either Python or JavaScript that are mainly used. So I'd say, yeah, it would be helpful to learn Python. But if you know C++, I don't think you'd struggle with Python, to be honest.
Yeah.
It should be very easy to pick up. And then, yeah, in terms of a starting point, I'd say, yeah, just experiment. So, like I said, Gemini, they've got a free API at the minute. So I think you can make 1,000 requests in a day. So it should be enough for you for any experiments you have. And everything I provided apart from the Gemini is all open source. So Chroma is open source. I showed how you can instantiate that, which is very easy through LangChain, as well as the Hugging Face embeddings. It's all very easy to set up an experiment on yourself. So I'd say if you want to go down that career path, just experiment, create a few projects, put them on your GitHub, and then when you're applying, you can show that you've created these sort of RAG architectures or whatever it may be that you want to create. And yeah, hopefully that works out for you.
Well, so means like I should start with learning Python, and then so there are a lot of career paths that companies are providing. So Google has one of the career paths like essentials in generative AI. Then Microsoft has a career path with essentials in AI, and like they have like started with the basics of what is LLM, what is generative AI. So before getting into LLM and all that stuff, I need to first understand Python.
I think if you want to create the systems around it, all I know, I'm only really versed in the Python side, to be honest.
Okay.
So my advice may be biased. So I would say Python is it's like a widely used thing within the AI space. I'd say it's the most widely used language in the AI space, to be honest. So yeah, I think you would benefit from learning Python. You certainly
Okay.
wouldn't harm your career prospects. So that's maybe where I would start personally. And then yeah, I think yeah, take those courses from Microsoft or Google. They obviously would take you down a structured path if you want to learn it. But then I'd also recommend experimenting and building your own systems as well, because the best way to learn is by just experimenting, tinkering with everything, just so you get a feel for how everything works. So that would be advice.
And all these projects I can get on this link that you had provided from GitHub.
The link that I provided on GitHub is for what I went over today.
Okay.
Okay, thank you for that answers. And we have Rahura as well. Can you please unmute and ask your question?
Thanks for the wonderful session.
So
on the last
the audio needs to be
Sorry, you're very quiet. I can't really hear that.
Can you hear me now?
Yeah, that's better.
But it's not there yet.
Perfect. Okay, thank you. So on the last agentic AI, right, which you mentioned, you will be using tool to connect to rack system, right? So you mean NCP tool which you are using, or how you are connecting?
Yeah, it can be through MCP. I'd say for external APIs, MCP is definitely something that's growing at the minute. To be honest, I haven't really played with MCP too in depth. It's currently something that I am looking to learn though. So yeah.
In this case, how you are connecting actually means to the tool.
With an MCP, you mean?
Oh. No, I mean generic way, the one diagram which you were showing, right? So how did you connect it actually? If you could show that diagram once again, please.
Yeah, I can put the diagram in the chat for you.
Sure.
May I ask a question?
Yeah, go ahead.
Yeah. Did you assess the performance of RAG against the root system without RAG?
Sorry, I didn't understand your question. Could you repeat that?
I wanted to know if you have an idea about the performance of the system that you planted this night against the normal, the standard way of chatting with LLM.
Yeah. So yeah, evaluation metrics. Yeah. So the reason I didn't include that within my notebook. So for evaluation metrics for RAG, what you'd need is a ground truth. So you'd need a subject matter expert to go through the documents. So let's say they create, for example, 100 sample queries. They would go through those documents and provide you a ground truth from the document itself. So based on that ground truth and the query that you get from the subject matter expert, then you can compare that to the answers your RAG gets. And then you can compare how accurate it is in terms of faithfulness to the source, as well as how the answer was outputted back to the user. So you can do many things. So there's many frameworks at the minute that do that for you automatically. So you've got things like Karagis that I've seen in use. So that's a package you can use, and that will explain how that's done.
Awesome. Thank you. We have Atul.
Hey, yeah, thank you. Abs, thank you for the nice presentation. Really illuminating. I
No
have a
worries.
couple of questions regarding chunking and also about evaluating your LLMs after you have gotten the response through RAG. So first about chunking, uh, how do you know what the chunk size should be and what the overlap size should be?
So I'd say it's a good question, and it's one that's very much dependent on your use case. The best thing what we did in practice, or the thing that worked for us, is just testing out multiple different chunk sizes, and using those to generate responses, and then obviously going back to the subject matter expert and getting them to sort of score those responses from the different chunk sizes. Obviously, a large chunk size will mean it captures a lot more information, but a smaller chunk size will mean it captures more specific information. So you could even do sort of like a two-stage process where initially you have a large chunk size and then you go ahead and create a separate vector store that has the smaller chunk sizes, or you could just experiment and see which works best for your use case. So that would be my advice there.
Okay.
And then
Yeah,
your second
that's
question was about evaluation, was it?
yes. So about so basically, I noticed that in your system prompt, you just had like I'm a helpful assistant.
Yeah,
However, you could like you do need some guardrails maybe to make sure that somebody does not inject malicious prompts into your
yeah, of
system,
course.
or and
Yeah,
also right. So
yeah, of course.
and also and then there's also like talking about evaluation, like as you're saying, like how did you evaluate that your system was spitting out what you wanted to spit out towards the end?
Yeah.
How did you evaluate this?
So ours is more of a manual evaluation because we were working directly with a business partner who wanted a specific sort of way the LLM generated responses. So it was more of manual evaluation. So all we did was we sort of created a Excel file with the responses that the LLM gave, and then they just marked it if it was what they were expecting, and if not, they provided some feedback. So based on their feedback, then yeah, we did some prompt engineering to sort of align the LLM to more of a response that was expected from the business. But the Raggis package that I put in the chat, that's something that I definitely would advise checking out. So that's a way to do that computationally. So all you'd need is a data set of those ground truths, and then it would allow you to do that automatically. So that would be my advice there.
Okay.
All right,
Right.
thank
Thank
you.
you.
Hi.
We have
I had a question too.
Yeah,
Okay.
go ahead.
Thank you. I was wondering if you have, are there any guidelines to the data sets that you put in to ensure that either chunking happens correctly or that just the responses are correct? Example being like, can you put the guidelines of the responses, of how they should communicate, like even tone of voice and whatever, in the repository of data? Can it be any type of old data that is in there, or is it better split up into different rags or?
Sorry, I'm not sure I understood the question.
Are there any guidelines to the data that is being put in to do the RAG
When you say
to make sure that
guidelines,
it
what do you
works?
mean?
Uh,
Guidelines for
Data should
splitting
be
or?
presented for structure of data that is in there, formatting style, type of data that should be in there to avoid, I don't know, confusion. As in, for example, you might have the guidelines of how you want the LLM to respond and act, and guardrails and such, and then you might have data related to the specific subject itself, maybe
Are
others.
you talking about the response to the LLM or a different part of the pipeline?
What do you mean with the response to the LLM?
When you say guidelines in there, I'm not too sure what in there means. Sorry.
Guidelines in there in the repository,
Which repository?
the one where you're putting all the subject matter knowledge,
You
the one
mean
that you're
the
using to
GitHub
get the
repo? The GitHub
yes,
repo that I created?
yes, to get the data for the
The
responses,
date?
the ground truths.
No, so I don't have any ground truth in there because I'm not a subject matter on AI safety. So unfortunately, I couldn't create an evaluation data set. So yeah, sorry about that.
But would you put it in there in that same location if it's put in there, or would you put everything in that one same database, or however you call it, or would you split it up into multiple to get the answers from the LLM?
So you mean when you've got an evaluation data set, does it need to go into the vector database? Is that what you're asking?
I'll pose it from a user perspective because I can't answer like that. I'm not technical. So I'm a user. You just said you just created a system that allows me to get an answer based
Yeah.
on the data set that I have provided. So I want the factual truth, but in that data from which it is drawing the answers,
Yeah.
are there any rules or guidelines for that data? Can it be all types of data, even the format in which I want my response? Or is that in different database?
Well, it depends on who you're creating the solution for. Let's say, for example, you're creating it for a business, then I'm pretty sure they wouldn't want their competitors' data in there. But if, say, you're creating it for yourself, then you wouldn't be able to use proprietary information to create a knowledge base because that's obviously protected information. So it really depends on the solution, I'd say.
But it doesn't change the quality of the output, or does it?
So the quality of
can you combine different things? Can you combine the guidelines of how you would like the response to come with the content itself?
Yeah, so for example, you'd set a system prompt, but in my example, it was just a very minimal one where I was just telling it to be a helpful assistant. But let's say, for example, you're creating a specified solution for say a financial team, then you can sort of align the LLM to act more with a financial persona. So it would act as a financial analyst. So you can align it to be that way as well. Yeah, that's possible.
And that
But
would
yeah,
be in the
again,
same database and not in separate. You wouldn't have different models acting in different ways to think of the solution. You could all do it in the same one.
When you say database, I'm getting a bit confused because the database is the vector store that we're creating that holds all our
Yes,
context, which is the
yes,
documents.
that's exactly there.
So do you mean can you have like different documents in there from different solutions?
Different solutions, but also different purposes, different guidelines. I don't know.
Yeah, you can do that. Sorry for the confusion. You can do that. It's not something I would recommend because, for example, let's say you've got a financial solution, but then you've also got one for, say, debt recovery. So they are semantically very related, but they're two very different solutions. So there could be a lot of overlap, and it could confuse the model as well based on the context it retrieves.
And if you
So
put
I'd
in
say
there the
if
persona,
if you, even
and
if
if
you
you put
put in
there
a
the persona, will it get
if you put
confused and not recognize that it needs to act according to that persona?
well, the persona at the end of the day depends on the context that's retrieved from your database. So let's say, for example, your database is retrieving incorrect context because you've got too many differing solutions, but are very semantically very similar. But the documents may use a lot of the same language but refer to different things based on the context it retrieves. That's the only thing that the LLM can act upon. So my advice there would be to, if you've got different solutions, then in the code you can see we set a collection name. So you can just set a collection name for each of your different solutions and then sort of query them that way. So it would be split up in that sense.
So also, if it's all the same solution, but you want to define the persona for that solution, would it get confused or and not know that it's the persona that it needs to act on, or would it know?
So you mean if you're setting a persona and you keep that persona for the other knowledge base?
No, for only one knowledge base, that one knowledge base, but in that knowledge base, there's the financial knowledge and the financial persona with which he needs to
Yeah.
reply, which has the guidelines, etc. Will it know,
Yeah.
or is it better in a different somewhere else to place that?
So the persona is something that you set in the prompt itself. It's not something that goes in the database, so it's something that you can change quite easily. Or you can
But
set sorry, go ahead.
I'm imagining a scenario where you don't want to enter that. You want it to always answer it in the same way.
Yeah, then you can, for example, where we set the chat history and we first provided the system message. When you, for example, let's say we're focusing on the financial persona, we can just hard code a system message, so finance system message, and then the way we provided those curly braces and just wrapped it, you can just wrap the persona that way. So it doesn't have to be something you're always typing in. You can have set ones, and then based on the LLM call you're making, you can just dynamically change them.
Okay.
If that makes sense.
Yeah, it does. Thank you.
Wow, thank you very much for that deep exchange of information. I believe so many people, including myself, picked one or two things from those exchanges. All right, we have three more people with questions. Kristen, can you unmute?
Yeah, there are actually so many Christians. So when you said Christian, I thought, yeah. So really good presentation. I actually have two questions. The first one goes like, given the absence like of a universal benchmark for hallucination, as mentioned across different domains, like how do you design like an evaluation framework that balances this factuality, context sensitivity, and domain specificity, if I would say? And the second question is like, what happens when you retrieve documents themselves are, let's say, noisy or conflicting?
I can answer the first question. So your first question was about creating a valuation data set for hallucinations.
Yeah.
Yeah, so like I've said before, that very much depends on the solution you're creating it for. So if we, for example, use the example of the finance team again, let's say you just prompt a raw LLM for some answers to get an idea of what sort of what sort of queries it hallucinates the answers for and which it doesn't. So you would, for example, create a evaluation data set of 100 queries. You would pass in those queries, get the answer, put it into your Excel file or however you hold in that data. But the main thing is you would need to sit with a subject matter expert, because unless you are the subject matter expert yourself, there's no way you would know if what it says is right or wrong, if you understand what I mean. So it all depends on the quality of the subject matter expert at the end of the day, and that they know a lot about the domain that you're creating the solution for.
Thank you.
Sorry, I didn't remember your second question.
The second question was actually like, what happens like when you retrieve these documents or data themselves and they are noisy or conflicting?
Yeah, if they're conflicting, then it can sort of confuse the LLM. So at the end of the day, it will still generate an answer, but it may not be the answer you're looking for because the context that it's received from your database is conflicting in itself. So that's why in the previous question, where it was asked if it's better to how you would handle that, my advice would be to split it into different collections for different solutions. That way, the documents you have in a vector database are all sort of related. And then there's no sort of overlap where, say, you're creating a solution for two different, say, teams that are semantically similar, but have different sort of outputs at the end of the day that they're expecting. So that would be my advice there.
Yeah, thank you.
All right. Next we have Anton.
Sorry, is that me, Sandeep?
Yes.
All right, okay. Uh, uh, Thank you, Abuzar. The presentation was really good, really, really insightful. The only question I have is, you used a Google um, Google API for
Yeah,
the
Gemini.
Google Gemini model, isn't it? My
Yeah.
question was, can we use an offline model downloaded from maybe Hugging Face instead of an online model? The idea being is if you are developing it for a company, they might be a bit reluctant to upload or upload their data or export Gemini to their data
The
because
internal
of
data,
data privacy and all.
yeah.
So an offline model may be a bit handy in such scenario.
Yeah,
Thinking.
yeah, I do know a lot of companies are going down that route at the minute where, for example, they fine-tune an open source model, because then at the end of the day they have access. Well, they know their data isn't going to be used by the say Google or OpenAI, whoever it may
Yeah.
be.
Yeah.
So that is a possibility. All you'd need to do is you'd need to download the models, so you can use things like OpenLlama. I've used Ollama before. I've never used Hugging Face for that purpose before, so I wouldn't be much help there. But with
Okay.
Ollama, all you need to do is you download the Ollama application to your computer, and then once you've downloaded it, then you can sort of download that specific model you want to use. And then the same way LangChain offered the Google Generative AI package, they also offer one for Ollama. So the abstraction again is held for you. So all you do is you host the model on your own server, and then it will be able to make those calls to the server that you've got it set up on. So yeah.
Okay. Performance wise, would that make a big difference, do you think?
Yes. So as I'm sure you're already aware, but LLMs run best on GPUs. So if you've got your own GPU, that's great. It could probably work quite well. But I personally don't have a GPU, so I wouldn't really recommend it. I would rather go for something like Gemini or something, because I know they're being hosted and the latency isn't anything to worry about. And for and then even in companies these days, you see they're doing that. They're just using OpenAI or they're using Gemini. So what they'll do is they will just speak to those vendors and have agreements where they can't train on their data. So that's a possibility too.
Right. Okay. Thank you. Thanks for your answer.
No worries.
All
Hi,
right.
Abuzar.
Thank you.
Hi.
Yeah.
Yeah, I have a question. I'm currently building a chatbot that needs to answer user questions using a strict decision tree logic, which is stored in a database. So within about like 20,000 possible paths. So based on the user's answers, the chatbot should return a predefined response from the decision tree. So how would you architect a solution for this kind of purpose?
I don't know. I'd have to think about it, to be honest. So you've got a decision tree in your database that you want every answer to follow. To be honest, it'd be best if you link with me on LinkedIn and give me some time to think about that. I don't have the answer on the spot, sorry.
Already did. Okay, thanks.
All right. Thank you. Dom, your question.
Hi. Yes, thank you. So thanks a lot for the great presentation. I'm really new to the AI space, and your presentation was very clear and helpful for someone who is a beginner like me. So really appreciate that. So
No
my
worries.
previous experience was in business intelligence, and therefore I have a question linked to that, especially with what you're doing with RAG, right? And my question is that because when I worked with business intelligence, there was crunching data in data warehouse that you give the right financial data or sales data for a corporate company. So how would you because my understanding is with LLMs is more with non-numerical information, so text information and so on. How could you combine a business intelligence solution together with your RAG solution that you've created so far?
So is the data for this business intelligence solution not text?
No, this is complete numbers. So it's in a data warehouse. So let's say you have your sales data for your company coming from SAP, right? And this is stored in a completely data warehouse. But it just has numbers. So for instance, you want to see let's say your sales in London for the last month, right? You have that broken down there. Maybe you can break it down to the week level, but there's no context information which I would hope that a RAG system could provide, right? Because all this information is within the let's say the corporate domain and not in a ChatGPT and so on. Do you understand what I mean?
Yeah, I understand what you mean. So it depends on how descriptive the data is. So for example, if it's a table that's you can tell based on the headings of the table what sort of the data is sort of referring to, then yeah, that's a possibility where you can create those embeddings for that as well. That is a possibility as far as I'm aware. Or you could do it in the traditional way where you do it through code. That's a possibility too, where you can have the LLM just so like I was talking about agents at the end, you can provide these agents coding abilities that they can run on their own. And then, for example, let's say it's in an SQL database, they can run that SQL query and get that sort of information to provide to the LLM. So that's a possibility too. It all depends how your data is held.
I see, I see. So I think if I understand you correctly, in order to use it the way you have it, you still need to get the numbers into the RAG model into the LLM somehow, or to get the agents to run it separately on their own to get the necessary information. Okay.
Yeah.
All right. All right. Thank you very much.
No worries.
All right. Thank you, Abuza, for answering all the questions there. Somebody I have a question. Tuju, would you rather the hacking? Is there any way that SME could be involved in RAG building, or if you could ask more directly, you can unmute.
Is there any way that SME could be involved in the RAG building? Sorry, I don't understand that question.
Put your hand. think we'll pass on that. Please, if you have further questions, try to connect with Abuza on LinkedIn, and
yeah, of course, I'm always available.
Definitely. All right. So, everyone, we want to hear feedback. This is a very exciting time for us. We want to know the next topics you want to see in our future event. Okay. Okay. Shishu said he got some audio
Yeah.
problems. Yeah. So please, we need your feedback. There's a Google form on the chat. Please tell us about your feedback, how you feel about this event, and what you'd like to say in the future event. And in the absence of any further question, that will be the end of today's call. Special thanks and appreciation to everyone that have decided to join us today. Special thanks to John from the other PyData community, and special thanks to Abuza as well for coming to share your experience and your knowledge, and of course answer all these fantastic questions. All right, so that will be the end for today. I do have a lovely weekend from wherever you are.
Yeah, thank you, Femi. Cheers.
Grace, do you want to close the meeting up?
I just want to say thank you to everyone that has joined us today. It's been really amazing. You all made our first event with PyData Milton Keynes a success. We cannot say thank you enough. We can't thank you enough for this. We are really thankful for your time, and we would really appreciate if you fill the Google form. We want to make sure that we put together events that you would like to hear from us. So let us know in the Google form if you would prefer to use the QR code as well to let us know what you would like to hear from us next time that we're having an event. Don't forget to follow us on Meetup. Our socials link is already in the meeting chat as well. If you would like to follow us on LinkedIn, on Twitter, you can also follow us on YouTube as well, so that you can see the recording of today's event on our YouTube. Thank you so much, guys, and until next time, hopefully we would see responses from the Google chat. Bye.
Cheers, bye.